Alrighty guys, so for today's lecture we are going to get into a topic called stoichiometry. Now before we get started, you're going to need a couple things for today's assignment. You're going to need your periodic table, as you guys can see on the screen, and you're also going to need a calculator. So just make sure you have those two things available while you guys are taking notes while watching this video. So before we get started, I do want to mention that stoichiometry is basically what we've been building up to. So learning how to balance chemical equations, molar mass, dimensional analysis, the whole point of learning all that is to learn stoichiometry. Stoichiometry is probably the most important concept or skill that you're going to need for chemistry, and we're going to be doing it for basically the rest of the year. So make sure that you guys have a good understanding of stoichiometry, because if you fall behind now, it's going to be very difficult for you to catch up, and eventually you will have to learn this in order to pass this class. So just make sure that if you have any questions, you guys let me know right away. Make sure you don't fall behind on this concept. But yeah, other than that, let's get started. So stoichiometry is pretty simple. You can look at it as one of two things. First of all, it's using dimensional analysis, I know your guys' favorite thing, to analyze chemical reactions. So when you're mixing chemicals together, you're usually trying to make something, right? So let's say, for example, you're like a pharmacist and you're trying to make Advil, okay? In order to make Advil, you're going to need a bunch of different chemicals. I'm really simplifying this concept, but the gist of it is you're going to have a bunch of different chemicals, right? You're going to have chemical 1, chemical number 2, and then there's probably a lot more chemicals you're going to use, but you're basically using these chemicals and combining them in a reaction to produce what you want to make. Now, you want to know, you're usually, when you make something, you're going to want to know how much you're going to make, right? So let's say, for example, you want to make like 100 grams of Advil. Now, in order to make 100 grams of Advil, you're going to need to know how much of each chemical you're going to need, right? So you're going to need a certain grams of the chemical number 1, a certain grams of chemical number 2, and you're going to need to know how many of these other chemicals you're going to need to make Advil, right? Like if you were trying to make a cake, you're going to want to know how much cake you're going to make. You're going to need to know how much flour you'll need, how much sugar you'll need, how many eggs you'll need. You're going to need to know how many ingredients you need to make that cake. Same thing with chemical reactions. You're going to need to know how many of each reactant you'll need in order to make your product. Now, unlike cake, where the worst thing that could happen is it tastes bad, or it catches on fire, or it burns, with chemical reactions, you can make a lot of hazardous and toxic chemicals, and you don't want to make too much. You want to make sure you know exactly how much of everything you're going to make, and that's what stoichiometry allows us to do. It helps you figure out how much product an amount of reactant can make, and vice versa. So how much product you can make using your starting number of chemicals. So that's stoichiometry. And so it's very important for chemistry. And when we do labs, you basically use stoichiometry to figure out how much product am I going to make? How much reactants do I need to make that product? And so this is kind of the core of our chemistry class. So the steps to do it are very simple. It's only 3 steps, and it's everything you've done before. It's first, you're going to balance the chemical equation. You're going to find the molar mass of the involved compounds. And then after that, you're going to do dimensional analysis. And we're going to go through 3 examples just so that you guys have a lot of information to go off of as you guys do your assignment today. Alright, so let's start with this question. So we have our chemical reaction right here. And so let's start off by just balancing it. We're going to do step number 1. We're going to balance the chemical equation. So what we're going to do is nothing new. We've done this before. We're going to count up how many of each element we have. So it looks like we have zinc, we have hydrogen, and we have chlorine. So we're going to set up our table and let's balance them out. So we're going to count how many zinc we have on the left side. We have 1 zinc, we have 1 hydrogen, we have 1 chlorine. And then we're going to go to the right side. We have 1 zinc, we have 2 chlorine, and we have 2 hydrogen. So it looks like that our zinc is balanced, but our hydrogen and chlorine are not balanced. So we're going to go to the side that has less hydrogen. Okay, the side that has less hydrogen is the reactant side, the left side. So we're going to need to add another hydrogen, but we can't just add hydrogen by itself. We have to add the whole chemical. So we're going to add HCl. So that means we're going to have two H's, right? Because we added one, we have 1, 2. And we have two Cl's. We have 1, 2. So we're going to have 2. So now everything is balanced. And so now we just need to write the coefficients. We didn't need to add any zinc, but we added 1 HCl. So we have 1, 2 HCl's, which means we're just going to put 2 in the front right here. Okay? So that's going to be our balanced chemical reaction. So we're already done with step 1. We balanced the chemical equation. Okay, so we have 2 in the front and we balanced. Now what we're going to do is we're going to find the molar mass of the involved compounds. Now in order to do that, basically this is telling us to basically look for your given and your end and just find the molar mass of those two things. So let's see how that works. So let's read the question. If you have 10 grams of liquid HCl and excess solid zinc metal, how many grams of H2 gas can you produce? Now, if you guys notice, we see the word excess, and it's excess zinc. We know that the word excess means there's so much we don't have to worry about it. So, since we see that word excess, you see zinc right here, we can just ignore it for the rest of the problem. We have so much, we don't need to worry about it. We can ignore it now. We don't need to look at zinc at all anymore. Okay, so I'm going to cross this out because we don't need to look at it. Now let's try to find our given and our end. Now, the end I think is usually easier to find just because it's always after how many, how much. So if we look at this problem, it says how many grams of H2. It says gas, but we'll ignore the gas for right now. How many grams of H2 gas can you produce? So we know that it's going to be grams of H2. So our end, what we're looking for at the end of this problem is grams of H2. Now for our given, what are we starting off with? It's usually the one with a number, right? It says if you're given 10 grams of liquid HCl, that means you have 10 grams of HCl. Okay, so that's our given and our end. Now, we're not done yet because it says to find the molar mass of these compounds. So we have HCl and we have H2. So if we want to look for the molar mass of HCl, what we're going to do is we're going to write molar mass of HCl. We just need to add H and Cl. So we have our periodic table. We have H, which is 1. We have Cl, which is 35.45. There's only one of each. So that means our molar mass is going to be 1 plus 35.45. So it's going to be 36.45 grams per mole for HCl. Okay, so I'm going to write that right here. So for HCl, we're going to have 36.45 grams of HCl, grams of HCl is equal to 1 mole of HCl. Okay, I'm going to write it like this because this will come in handy later on. Okay, that's just grams per mole. Okay, for grams of H2, H2 is really easy. H is just 1. So 1 plus 1 is 2, so that means for H2, the molar mass of H2 is going to be 2 grams per mole. So what we can do here is we can just write 2 grams of H2 is equal to 1 mole of HCl, or H2, sorry about that. Okay, so we did step 2. We found the molar mass of the involved compound. So we're more than halfway done. All we need to do is dimensional analysis. Okay, so I'm going to clean up the screen real quick, but I'm going to leave the molar masses. Okay, so again, the first thing we're going to do is we're going to balance the chemical equation, and then after that we find the molar mass of the two involved compounds, which we did. I'm going to write the balanced equation right here just so that we have a reference to it. So we're going to go down. Okay, so when we are doing the dimensional analysis, the last part of stoichiometry, we're gonna follow a very set pattern for all of them. Okay, so sorry, let me finish writing this real quick. Okay, so this is the pattern you're gonna follow. For the dimensional analysis, we're gonna have 4 steps. What we're gonna do is we're gonna write the grams of the given chemical, which in this case is going to be HCl. We're gonna turn it into the moles of the given chemical, which is still HCl. So we're gonna turn grams into moles, and then we're gonna turn the moles into the end, what you're looking for, which is gonna be H2, and then you're gonna turn it into grams. So there's gonna be 3 fractions. This is gonna be fraction 1. This is gonna be fraction 2. I'll just write 2. And this is going to be fraction 3, and that's gonna give us our answer. So I know it looks very complicated, but this is pretty simple once we go through it. So let's start with our grams of our given chemical. So if you guys take a look back at the question asks if you have 10 grams of liquid HCl. Okay, so that's our starting number. So what we're gonna do is we're just gonna start just regular dimensional analysis, and we're gonna write 10 grams of HCl, and we're going to set up a fraction. Okay, now we know that grams of HCl is not what we're looking for. What we're looking for at the very end is grams of H2, which means we're going to get rid of this. In order to get rid of grams of HCl, we just need to put it on the bottom. Okay, we're going to put grams on the bottom, and that way they can cancel out with each other. Now, in order to cancel them out, we need to put something on the top of this fraction too. And so that's where the second step comes in. The second step is where we're going to put moles of HCl. So we're going to use grams and moles on the same fraction. Okay? So, we have grams of HCl on the bottom, moles of HCl on the top. And where do we get the numbers for this? We get this from the molar mass right here. Grams of HCl equals moles of HCl. So I'm just going to copy this down right here at the bottom. 65.45 grams of HCl equals 1 mole of HCl. And this is where we're going to get our numbers. Okay. The first fraction, we get the numbers from the molar mass. Okay? So, what number is next to grams of HCl? The number that's next to grams of HCl is 36.45. So we're going to put 36.45 on the bottom. What number is on next to the moles of HCl? It's 1. So we're just going to put 1 on the top. And like we said, the grams of HCl cancel out with each other. Alright, let's set up our next fraction. Okay, we have moles of HCl, but we want to get rid of it. So we're going to put moles of HCl on the bottom. Okay, so what we did here was we started with grams of HCl, and then we did that, and then we turned it into moles of HCl. So here we're going to have to turn it into moles of H2. We're going from fraction 1 to fraction 2. That means on the top of fraction 2, we need to put moles of H2. Okay, so where do we get the numbers for this fraction? For the second fraction, you're always going to get the numbers from the balanced equation, the balanced chemical equation. And this part's really easy. Once you've balanced it, all you need to do is look for those chemicals and just write the coefficients in the front. So what do I mean by that? So on the bottom, we have moles of HCl, and we want to cancel it out with the other one. So we're going to look for HCl in the chemical equation. If you look for HCl, what number is in front of HCl? It's the number 2. So we're just going to put the number 2 in front of moles of HCl, because chemical equations are talking about moles. And then for the top, moles of H2, we just look for H2. What number is in front of H2? There's no number. If there's no number, it's the same thing as the number 1. So we're just going to put 1 right here. And there you go. We set up the second fraction. So the first fraction, we use the molar mass, The second fraction, we use the balanced chemical equation, and now we can finish up the problem with the third and final fraction. Okay, so for the third and final fraction, we want to get rid of moles of H2, so we're going to put moles of H2. And then on the top, we want to find this last fraction. So we did fraction 1, we did fraction 2. Now for the third fraction, you want to go from moles to the grams. So we're going to put grams of H2 on the top. And that way the moles of H2 can cancel out with each other. Okay, if you notice on this fraction, we have grams and moles. If you have grams and moles on the same fraction, you're going to get the numbers from the molar mass. Okay, so we're going to get the numbers from the molar mass. This time we're talking about H2, so we're going to use this equation right here. We have 2 grams of H2 is equal to 1 mole of H2. And so we just need to put the numbers in the right spot. On the bottom we have moles, so we're going to put 1 in front of moles because there's a 1 in front of moles. And on the top we have grams, so we're going to put 2 on the top because it's grams. Alright, and there you go. You guys have done the hard part. All we need to do now is plug and chug into the calculator and we can get our answer. Now, just to make sure that we set everything up correctly, you have grams of HCl here and on the bottom, moles of HCl on the top and on the bottom, moles of H2 on the top and the bottom, and all we have left over is grams of H2, which is what the question was looking for. So that's it. That's what we're looking for. We set everything up correctly. Alright, so what we're going to do now is we're going to solve out this equation. Okay, so let me just clear out right here. Okay, so we're just going to go into our calculators, and it's the same thing as normal dimensional analysis. We multiply the tops and divide by the bottoms. So our starting number, the first number that we have is 10. So we have 10. And then we can go to the first fraction. We have 1 on the top, but we don't need to multiply by 1 because it's the same number, so we can skip that. On the bottom, we have 36.45, so we're going to divide by 36.45. The second fraction, we have a 1 on the top, which we can ignore. We have a 2 on the bottom, so we divide by 2. And then on the third fraction, we have a 2 on top, so we're going to multiply by 2. We have a 1 on the bottom, so we can ignore that. So there you go. We have our answer right here. Our answer is going to be 0.274, and the units is grams of H2. Okay, so what does this tell us? This tells us that if you have 10 grams of HCl and you use this reaction, if you do this reaction, if you have 10 grams of HCl with excess Zn, zinc. So if you mix these two things together, that means you are going to produce 0.274 grams of H2. That's basically what all this math, all this chemical equation is telling us. If you have 10 grams of HCl, you have excess zinc, you're going to produce 0.274 grams of H2. And that is how you do stoichiometry. Alright, so I know that was a lot of work. It's very complicated, but the more you do it, the easier it will get. So I'm going to go over another problem, a stoichiometry problem. But guys, just remember these 3 steps. The 3 steps are to balance, to find the molar mass, and to do dimensional analysis. One other thing I like to teach and I like to use in order to remember, if you guys notice, we set up 3 fractions, right? We had grams, we had a fraction, and on the top we had moles, and then we had another fraction where we had moles, and then we had grams. If you want to know if you set up your fractions correctly, I like to remember this phrase right here. Just look at the tops of the fractions. The tops of the fractions should give you G, M, M, G. So G, M, M, G. The tops of your fractions should always have those 4 things, and that way you know that you set up your fractions correctly. Easy way to remember that I like to teach is gamamaga. Okay, so gamamaga. So remember that weird sound, gamamaga, and you will always set up your fractions correctly. Okay, gamamaga. Just remember that. Okay, let's go on to the next example. So in our next example, we have to balance again, and we need to do the molar mass. So let's follow the steps. The first thing we're gonna do, the first step is we're gonna balance. So let's balance this out. So on the left side we have H and O, and on the right side we're also going to have H and O. So how many hydrogens do I have on the left side? I have 2. How many oxygens? I have 2. And then on the right side, I have 2 hydrogens and 1 oxygen. So it looks like I have fewer oxygens on the right side. The oxygens are not balanced. So what I'm going to do is I'm going to add another H2O. That means on the right side, I'm going to have 2 oxygens and I'm going to have 4 hydrogens. Okay, now the H's are not balanced on the left side, so I'm going to add H2. And if I add H2, I have 2, 4. So now everything is balanced. So I just need to write the coefficients now. So I'm going to write 2 in front of H2 because there's 2 of them. I don't need to write a number in front of the O2. And then for the H2O, I'm going to just write 2 because there's 2 of them. Okay? So there you go. The balancing for that was pretty easy. And so now we can do step number 2. Step number 2 is to find the molar mass. Okay, the molar mass. So let's read the question and figure out which chemicals are the important ones. So if we have 40 grams of H2 and we have excess O2, so we see that word excess again. Excess what chemical? O2. That means that we don't need to worry about O2 in this problem. We don't need to worry about O2, so we can ignore that for now. And it's asking us how many grams of H2O will be produced. So just by reading this question, we see that we have 40 grams of H2. This is going to be our given. Our given is going to be H2. And what we're looking for at the end is going to be H2O. And now we just need to find the molar mass of those chemicals. So again, H2 is really easy. We did this already. H2 is just hydrogen and 2 of them. So 1 plus 1 is 2. So H2's molar mass is going to be 2 grams per mole. For H2O, we have 2 H's again, so that's 1 plus 1 since there's 2 of them. And then there's O, which is 16. So 1 plus 1 plus 16. So 2 plus 16 is going to be 18. So H2O is 18 grams per mole. Alright, and there we go. We did steps 1 and 2 really quickly. We did the balancing. We did the molar mass, and now all we need to do is solve out our problem. So remember that phrase, guys, gamamaga, gamamaga, and we can set up our fraction. Actually, let's actually do it that way. We can just set up our fractions right away. We're gonna have grams. We're gonna set up a fraction, and then we're gonna put moles, right? Gamama, and then the third fraction we're gonna do moles, g. And then the last fraction we're going to do grams. So if you feel more comfortable doing this, you can just set up your fractions first and then just fill it in as you go along. Okay? Alright, so if you want to set it up even further, this is another tip that you can use. The tops of the first 2 fractions are going to be about your given chemical. And then the tops of your last 2 fractions are going to be about your end chemical. So in this situation, our given chemical is going to be H2. And the end chemical is going to be H2O. So we can just plug those in. So the tops of the first 2 fractions are going to be about H2. So grams of H2, moles of H2. And the end chemical is going to be for the third and the fourth. So H2O, grams of H2O. Okay, so we've set up most of our fraction already. We just need to plug in the bottoms and the numbers. So let's do that. So we know that the first one right here is just going to be our given. So our given is 40 grams of H2. So we're going to write 40 grams of H2. We said earlier that the first fraction, we get the numbers from the molar mass. Okay, so here we have the molar mass of H2. H2 is 2 grams per mole. And this is the same thing as 2 grams equals 1 mole. So we have moles on the top, and we want to get rid of grams of H2, which means we're going to have to put grams of H2 on the bottom. And the reason we do that is just so that we can cancel them out. Okay, the number next to grams is 2, so we're going to put a 2 on the bottom. The number next to moles is 1, so we're going to put a 1 on the top. So we're going to put a 2 on the bottom, 1 on the top, and the grams canceled out. Alright, let's move on. The second fraction we said earlier is going to get the numbers from the chemical equation. Okay, so we're going to use this right here. Now, before we do that, let's cancel out moles of H2. We want to get rid of moles of H2, so we're going to put moles of H2 on the bottom, and those are going to cancel out. And the number next to H2 is going to be 2, and the number next to moles of H2O in the chemical equation is going to be 2. So we're going to put 2 and 2. So we're going to put 2 on the top, 2 on the bottom. Now, if you guys notice something, you're going to notice that there's a 2 on the top of this fraction and a 2 on the bottom. So we can actually cancel that out too. So the 2's cancel out as well. We have moles of H2O on the top here, so we're going to put moles of H2O on the bottom. And that way these can cancel out, because we don't want moles of H2O, we're looking for grams of H2O. Now for the last fraction, like we said earlier, we're going to get the numbers from the molar mass. The molar mass of H2O, we found it right here, is 18 grams per mole. So this is the same thing as 18 grams equals 1 mole. So we have moles on the bottom, so we're going to put a 1 next to moles, and we have grams on the top, so we're going to put 18 on the top. And there you go. We basically filled in our entire fraction. All we needed to do was just use the information that we found earlier, and now we can just plug and chug this into our calculators. Okay, so let's plug it into our calculators. So we start with the number 40, and then we have a 1 on the top, 2 on the bottom. So we're going to divide by 2. The second fraction, if you notice, everything got canceled out. The 2's cancel out, moles canceled out, so we can just skip that fraction completely. And then for the last fraction, we have 18 on the top, 1 on the bottom, so we're going to multiply that by 18, and there you go. Our answer is 360. So that means for this problem, that final answer is going to be 360 grams of H2O. Okay, so again, if we just kind of write down in regular terms what this means is, it means that if we have 40 grams of H2, we combine that with a lot excess O2, that's going to produce 360 grams of H2O. Okay, and that's what this problem is telling us. Okay, so again guys, just remember the 3 steps. You want to balance, molar mass, and then do dimensional analysis. And when you're doing your dimensional analysis, remember the phrase gamamaga, because it'll help you set it up. Now, I know that the lecture has gone on long enough already, and so if you're good with those 2 examples, you guys can get started on the assignment right now, but I am going to go over a 3rd example just in case you guys want the extra example. And if you feel confident trying this on your own, feel free to pause the video and try number 3 without me, and then check your answer at the very end. But if not, that's okay. I'm going to go through it step by step with you guys. Okay, so let's do our final example. So here we go. We have our equation, and then we have our problem. So let's start off with the first step. As always, we're going to balance the chemical equation. We're going to balance this. Okay, step 1, it's balance. So on the left side, we have N and H, and we also have that on the right side. On the left side, how many N's do we have? We have 2. How many H's do we have? We have 2. On the right side, we have 1 N, and we have 3 H's. Now the N's are not balanced, so I'm going to add another N to the right side, NH3. The N is going to turn into 2, because there's 1, 2. And then the H is going to turn into 6, because there's 3, 6. Now the H's are not balanced, so I'm going to add H's until they balance out. So if I add another H2, I have 2, 4. And so if I add another one, I'm going to have 2, 4, 6. So I'm going to have 6 total. So now they're balanced out. So we just need to write the coefficients now. We have 1, 2, 3 H's, so I'm going to put a 3 in front of the H2. And I have 1, 2, NH3, so I'm just going to put a 2 in the front. And there you go. We've balanced everything out. Alright, we're going to do step number 2 now. Step number 2 is to find the molar mass. Okay, so we're just going to add them up. So let's read the question and figure out what are the important chemicals. So it says we have 12 grams of N2, and since that chemical has a number, we can already tell this chemical is going to be our given chemical. React with excess H2. So H2 is excess, which means we can ignore H2. We're just going to cross it out because we don't even need it anymore. We can ignore H2. How many grams of NH3 will we produce? It says how many grams of NH3. So we know that NH3 is going to be our end chemical. Okay, so we set up, we balanced the chemical equation, we found the molar mass, and now all we need to do is do the dimensional analysis. Now again, we're going to set it up using that amazing phrase that sounds really weird but is very helpful, g-m-m-g. Okay, so first fraction is g, grams. We're going to set up our fraction. First one, g-m-m, so that's going to be moles. Second fraction, g-m-m, so moles. And then g-m-m-g, the last one is going to be grams. Okay, so g-m-m-g. Now we also said earlier that the first two fractions are going to be about the given chemical. So our given chemical is N2. So the first two fractions are going to be all about N2 on the top. So we're going to put N2 on the top, we're going to put N2 on the bottom, and then the last two fractions we said earlier are going to be about the end chemical. Now our end chemical is NH3, which means that we're going to put NH3 on the tops of the last two fractions. So our end chemicals is NH3, so we can just plug in NH3 on the top, NH3 on the top. So the first two fractions are about, the tops are about N2, the given, and the last two are going to be about the end chemical, which is NH3. Okay, so we just need to plug in the numbers and the bottoms now. Okay, so let's plug in our first number. Our first number is going to be our given number. It's going to be 12 grams of N2. So we're going to write 12 grams of N2. Now, we want to get rid of grams of N2. We want to cross this out, right? To cross it out, we need to put it on the bottom right here, grams of N2. So this can cross out. Okay, first fraction, the numbers are going to come from molar mass. And obviously, it's going to be N2 because that's the chemical we're talking about. Oh, we didn't find the molar mass. I'm so sorry, guys. I skipped that completely. Let's do the molar mass. For the molar, I got too excited. For the molar mass, we have N2, so there's two N's. N is the number 14. So 14 plus 14 is going to give you 28. So our molar mass for N2 is going to be 28 grams per mole. And then for NH3, N is 14, H is 1, and there's 3 of them, so plus 1, plus 1, plus 1, which is plus 3. 14 plus 3 is going to be 17 grams per mole. Sorry about that, guys. Totally forgot to do the molar mass. I just got so excited setting up the dimensional analysis. Okay, so the molar mass of N2 in this first fraction is 28 grams in 1 mole. And so we're just going to plug the numbers in. The grams is 28, and that's on the bottom, so we're going to put 28 on the bottom, right, because there's grams of N2, grams, and then moles, the number 1 is next to it, so we're going to put 1 on the top. Let's move on to the second fraction. We have moles of N2, and we want to get rid of moles of N2, so we're going to put moles of N2 on the bottom. We said for the second fraction, we're going to get our numbers from the balanced equation. Okay, so we're going to look for NH3 and N2 in the equation. So NH3 has the number 2 in front of it, so we're going to put 2 on the top. N2 has no number in front of it. No number means 1, so we're going to put 1 on the bottom. And then last step, we're going to cancel out moles of NH3. So we're going to put moles of NH3 on the bottom. That way they can cancel out. And we said earlier again that the third fraction, we're going to get the numbers from molar mass. And we just found out that NH3 is 17 grams in 1 mole. So we can put grams on the top, 17. We can put 1 on the bottom. And there you go. We've set up our dimensional analysis problem. Alright, now all we need to do is solve out the problem. So I'm going to pull out my calculator, multiply the tops, divide the bottom. So the top, we're going to start with 12. There's a 1 on the top, so we can ignore that. We're going to divide by 28. We're going to multiply by 2 on the top. We can ignore the 1 on the bottom. And then lastly, we're going to multiply by 17. And that is going to give us a final answer of 14.571 grams of NH3. Alright. There you go. That's going to be our final answer. And again, just so that we can kind of root this in reality, that means if you have 12 grams of N2 and then you combine it with excess H2, that means you're going to make 14.571 grams of NH3. Okay? Alrighty guys, so that's going to be all the examples for today. I know the lecture was very long, but hopefully these examples will be helpful for you as you guys do your assignment. Let me know if you guys have any questions, and we'll see you guys next time.